Hello, welcome to my channel. Now in this video, we want to solve the limit of the second question. So in a previous video, we looked at the limit of 1 minus cosine theta over theta as theta tends to 0, which was quite fun, right? So in this second question, we're going to be looking at the limit of tangent of x over x as x tends to 0. Okay, and here we have a basic tool to guide us. The tool is this, that the limit of sine of an angle over a denominator, and the denominator is the same thing as the angle. As that denominator tends to 0, the result of that limit is going to be 1. So whenever you have this and this to be the same, right, what we write here and what we write here, they're the same, and it is actually approaching 0, then the result of that limit is 1. I have proved this in one of my videos, right, which I used the unit circle, which is a little bit complicated though, but it was quite fun. Great. So let's look at it. So we have the limit of tangent of x over x as x approaches 0. Well, I'm going to write tangent of x in terms of sine and cosine, all right, which we have it to be tangent x to be sine x over cosine of x. So let me rewrite the function first, then we take the limit. Right. Sine of x divided by cosine of x. That is just the tangent, all right? And you know now we have a fraction divided by x. Okay, now this is how we do. We'll go ahead and, since we're having division of two fractions, okay, so we'll go ahead and rewrite it, and then we are going to enter with sine of x divided by x times cosine of x. Okay, great. Now, I would also like to split this fraction into two parts, all right? Since this is a product, so this is how I would choose to write it. This is sine of x divided by x times, I'm now going to push this 1 over cosine in front, right? This is 1 over cosine of x. Great. Okay, so you see there's nothing really big there. This is sine x, I put it here, and now give it only this denominator, which is the x. I'm now multiplying it with 1 over cosine. So if you multiply these two fractions again, you're going to enter with what we had initially. Okay, so we have to take the limit as x tends to 0 of this, and I've rewritten it as this. So we're still going to have to take the limit as x tends to 0 of the product of these two functions, all right? Good. Maybe let me do this. Now, you know of a rule, okay, from rules of limit, that the limit of the product of two functions is the product of the limit of those two functions, right? So this is it. So I say the limit as x tends to 0 of sine x over x times the limit as x tends to 0 of 1 over cosine of x. Okay, that's better. And now from this our tool, we know that the limit of sine x over x as x tends to 0 is 1, right? Because the angle and the denominator are the same. Okay, we multiply it with, and now the limit of 1 over cosine of x as x tends to 0. Well, as x tends to 0, cosine of x tends to 1, all right? So the numerator is just a constant, so we can just put that constant there. And then the denominator is cosine of x. So as x tends to 0, cosine of x tends to 1. That is the denominator here. We have it to be 1. So all in all, we're going to enter with 1 times, another fraction is going to give us 1. Okay, so we're going to enter with 1 times 1, which is just 1. Wow, that's nice. So that tells us the limit of this function as x tends to 0, okay, the limit of tangent of x over x as x tends to 0 is equal to 1. Okay, great. All right, thanks for watching. Please subscribe to my channel.